Hi, my name is Jessica, and I will be doing a Pencast for homework number 1, problem number 38. The question I have written here with the figure that's in it, as well as an equation that we will be using for it as well. And the question is, what is the force on the 5 NC charge in figure 25.38? And then it wants to answer as a magnitude and an angle measured clockwise or counterclockwise from the positive x-axis. So I'm going to start by labeling the charges. This is going to be charge number 1 because that's going to be our focus charge. This will be charge number 2 and charge number 3. So to start off, we need to find the total force on this guy pretty much. So we'll start with the force that 2 brings on 1, which is going to be a downward force since they're both positive, repelling each other. And then the force for 3 on 1 is going to be positive going up towards that direction. So that one will have an x and y component. This one will solely just have the y component, so we don't need to worry about the x. So it'll just be one calculation. I have all the numbers calculated already, so I won't be showing like my calculator or anything like that, but we'll go ahead and get started. So we're going to be using this equation for basically each part, just in different forms, different ways, basically doing the different numbers. So to convert everything, 3 centimeters is going to equal 0.03 meters. So then same with the 4 centimeters will be that. And then we need to find this distance as well, which is just going to be the square root of 3 squared plus 4 squared. It's going to equal, we'll just make that x. So this is just 9 plus 16, which is going to be the square root of 25, which equals 5 centimeters, which will be the that's a m there. And then for all of these, we know that n is to the negative 9, so it's 5 times 10 to the minus 9 coulombs. This will be 10 times 10 to the minus 9 coulombs, and this will be negative 10 times 10 to the minus 9 coulombs as well. Sorry, my paper is going to be moving a lot. Alright, so for the force of 2 on 1, it's going to equal k times charge of 1, charge of 2, absolute values as well, with the distance between them squared. So this will be a tight squeeze, but k is 8.99 times 10 to the minus 9 Newton meters squared per coulomb squared. And then we have 5 times 10 to the minus 9 coulombs times 10 times 10 to the minus 9 coulombs. And that's all going to be over this 4 centimeters squared. So I like to write it like this, so then my units easily cancel out there. And for the F2 on 1 total, like I said earlier, I've already done all the calculations for this. So we get 2.8 times 10 to the minus 4 newtons in the j hat direction. And this number will also be negative since it is in the negative y direction, since it is a repulsive force. So now for F3 on 1, we're going to get the same thing, but with charge of 1 and charge of 3 absolute value again, so we don't have to worry about this negative at all either, since it is absolute values. So for that, it's going to be the 8.99. Oh, and this is a 9, not a negative 9 up there. Squared per coulomb squared. And pretty much again, same thing here. But then the r will be a different number. It's going to be this distance here, which we calculated to be the 0.05 meters. Since we don't need this distance or this distance, we want the straight distance from charge 1 to charge 3. So we get negative 9 times 10 times 10 to the minus 9 coulombs over 0.05 squared meters squared. Get rid of all of our units that we no longer need, so we end up with the newtons again. So for F3 on 1, we get the answer to be 1. Let's see, where is it? 1.79 times 10 to the minus 4 newtons. Alright, and so to get the x and y components, we're going to multiply this answer. For the x component, it's going to be cosine, since we're trying to get this angle here. So cosine is the opposite, or the adjacent, my apologies. So the cosine is adjacent over here to get that x component. So cosine, and then we're going to add that with the sine of it. This will be I hat, and this will be the j hat, so we can add this later to this answer. And to get theta, it's inverse tangent of that 0.04 meters 0.03 meters, which equals 53.12 degrees. So then I've done that calculation as well, so it'll basically be this times the cosine and then this times the sine. So we get F3 on 1 to equal 1.07 times 10 to the minus 4 in the I hat plus 1.4 times 10 to the minus 4 in the j hat, and that is going to be in newtons. So now, to get the total of F on 1 in that y direction, since we have two components in that y hat in the j hat direction, the y direction, we're going to add that 1.4 times 10 to the minus 4 j hat, and then it's going to be minus this one, since this is in the negative direction, but this y component is going to be in the positive since it's going up. The x is also positive as well since it's going to the right and not the left. So it's going to be minus that 2.8 times 10 to the minus 4 j hat, which will equal 1.4 times 10 to the minus 4 j hat newtons. You can probably switch these actually, so we'll do newtons j hat. My handwriting is very messy, I apologize. Alrighty. So then, to get the total of F on 1 total, it's going to be the x, so it'll be I hat, number I hat squared, plus number j hat squared over the square root. Basically the x and the y components are going to be squared, kind of like the Pythagorean theorem type of thing. So to plug that in, it will be that x component that we found here, since that is solely the only x component, since charge 2 does not have an x component, it just has the y. So it'll be 1.07 times 10 to the minus 4, and we square that. And then we're going to add it to this one squared, since that is the total y component squared, and I have that answer. So F on 1 total is going to equal 1.76 times 10 to the minus 4 newtons. So that's going to be the total force. And then I wanted it in the magnitude and an angle measured counterclockwise or clockwise from the positive x-axis. So to do that, again, we will use tangent theta equals opposite over adjacent. I always have to think about SOHCAHTOA to make sure I'm doing the right ones. So then the opposite is just going to be the y, and then the adjacent is going to be the x, so theta equals the inverse tangent of 1.4 times 10 to the minus 4 all over the 1.07 times 10 to the minus 4. So we get theta equals a 52.6 degrees. So if we add up the vectors, so this is going to be 1 here in the point charge. So 2 is going down this way, and then the force from 3 is going to go up that way. So if we add this vector and move it down here, it's going to be going this way. So our total vector is here. So this theta is this angle, so it will be 52.6 degrees clockwise from the positive x-axis. Alright, I think that is it. Hopefully I explained it well enough, and all my calculations were done previously ahead of time, so I didn't have to worry about doing them now. But hope you got something out of it.